Hello there and welcome to lesson 19 in the series to learn programming in Scratch. In this lesson, you're going to learn more about the SKA telescope in the Karoo that can detect objects that are far away from Earth in space, and then you will write a program that shoots asteroids with a laser cannon. The SKA project is an international effort to build the world's largest radio telescope, which will eventually cover more than a square kilometer, that is 1,000,000 square meters. Unlike telescopes using one big dish, the SKA consists of many individual antennas. The SKA telescope consists of 197 antennas. 133 antennas were added to the existing 64-dish meerkat in the same area. The Karoo in South Africa and an area in Western Australia has been selected to construct these antennas because there are very few other signals that can interfere with the reception in these remote locations. The project will bring together some of the world's best scientists, astronomers, and engineers. The system will require supercomputers and network technologies that will generate more data traffic than the entire internet at the moment. Astronomers will use the SKA to understand how stars and galaxies are formed and how they have evolved, and they might even track life elsewhere in the universe. Although an asteroid collision with the Earth is unlikely, it would have a devastating impact on the Earth. Better telescopes make it possible to be warned of any danger earlier. If an asteroid comes close to Earth, it will be demolished or its direction will be altered with nuclear explosions. Now answer the questions on this topic in your workbook. Now let's look at the new Scratch blocks that you can use for today's program. This purple block from the Looks group changes the sprite's costume to a specific costume. You have used Next Costume before, but if you want to make sure a sprite displays a particular costume, this Switch Costume block is more suitable. For example, use the arrow sprite, and when the right arrow key is pressed, show the right arrow key. And then when the left arrow is pressed, show the arrow pointing to the left. Now the arrow pointing to the right will display when you press the right arrow, and the arrow pointing to the left will display when you press the left arrow key on the keyboard. You can display the direction on stage by checking the box to the left of the block, like in this example. This blue block from the Motion group will place the sprite in a particular position horizontally. This blue block from the Motion group will place the sprite in a particular place vertically without affecting the horizontal position. For example, these blocks will place a sprite horizontally in a random place, but always right at the top of the stage, like in this example. This blue block from the Motion group will move the sprite 10 pixels to the right on stage because the X values increase from left to right on the stage. This blue block from the Motion group will move the sprite 10 pixels higher up on the stage because the Y values increase from the bottom up. This loop will let the sprite move lower and lower on the stage until the sprite reaches the bottom of the stage. Here's an example where it was done. This blue block from the Motions group turns the sprite towards the position of the cursor on the stage while the program is running. The block is used in a loop to continuously keep track of the cursor's position. Like in this example, this loop will continuously move the sprite towards the mouse cursor on stage so that it follows the mouse pointer. Like in this example, this loop will continuously move the sprite towards the mouse cursor on stage so that it follows the mouse pointer. And the last block for today, This blue block from the sensing group checks whether the computer mouse's click button is down. If so, the block is true, and if not, the block is false. For example, this if block sends a message to fire a missile if the mouse click button is down. Now let's create a game in Scratch with a stars background. Save the program as Asteroid. Draw or import the necessary sprites for the cannon, missile, and an asteroid. Code an asteroid that repeatedly falls from the top of the stage down to the bottom of the stage and disappear. Code a cannon that shoots at the asteroids with missiles. Change the direction of the cannon to follow the mouse cursor and shoot when you click the mouse button. When the missile strikes the asteroid, there must be an explosion. Save all the changes to the program. Here is an example of what your program might look like. By now you know how to use the design cycle. Write down any questions you have about the exercise in your workbook. Discuss it with your friends, use the internet to find answers or the sprites that you might need. Think about different solutions. For instance, you will use all the examples and new blocks that you've learned about today. And you don't have to import an asteroid and a cannon. You can use a simple triangle, diamond, or a circle. Draw the design for the background and the position of the sprites. Label the sprites in your workbook. Write down the algorithms for the asteroid, one for the green flag is clicked and another one for when the asteroid receives the message to explode. Write down the algorithm for the cannon or use the algorithm in your workbook. And write down the algorithm for the missile or use the algorithm in your workbook. Code your program and check that your program meets the criteria against this rubric. A more detailed rubric appears in your workbook. Use your 6 thinking hats again to reflect on what you've learned today. In the next lesson, you will write a ping pong game. The aim is to hit a bouncing ball with a paddle. Until then, goodbye.